Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we're given a function that is uniformly distributed, and we're asked to find a couple of expected values. Now, before we get started, make sure to subscribe to the channel for notifications on more math tutorials. All right, now let's take a look at this example. Our example says an insurance policy is written to cover a loss, X, where X has a uniform distribution on the interval 0 to 10, and the policy has a deductible of 2. We're asked to calculate the expected value of the insurance payment, and then we're asked to calculate the expected value of the unreimbursed portion of the loss. Or in other words, how much the insured person would need to pay. So let's start to work on this. Because we're being asked to find expected values, let's review the expected value formula for uniform distribution. It says the expectation of X equals the integral from A to B, where A and B are points in our interval, of X times 1 over B minus A dx. Now let's take inventory of what we were given in our example. In our example, we were given an X with uniform distribution on the interval 0 to 10. We were also told that X represents loss. And lastly, we were given a deductible of 2. Now the first part of our problem asks us to calculate the expected value of the insurance payment. And what this is really asking us to do is to calculate the amount that the insurance company would pay in the event that there's a loss. So let's think about this, right? When an accident happens, how much does the insurance company cover? Well, the insurance company covers the total loss minus the deductible. Now we were given loss as X and the deductible as 2. So the only thing that we don't know is the insurance payment, and we can assign the variable Z to that. So let's take a look back at our expected value formula. It says the expected value of X. However, the variable that we don't know right now is Z. So we have the expected value of Z equals the integral from A to B of Z times 1 over B minus A, and we're still integrating with respect to X. So we've got a function for Z, which is X minus 2. And the last piece that we need before we start to integrate are the bounds of our integral. So on our given interval of 0 to 10, when will the insurance company actually make a payment? The insurance company will make their payment between 2 and 10. Right? So that's between when the loss equals the deductible and the upper bound we were given, 10. So now plugging into our formula, we have the expected value of Z, our insurance payment, equals the integral from 2 to 10 of Z, which is X minus 2, times 1 over B minus A. And this A and B will be the original interval that we were given. So that's 10 minus 0 dx. The first thing that I'll do is move our constant to the outside of the integral. And at this point, I'll go ahead and integrate. We have 1 over 10 times x squared over 2 minus 2x, and that's from 2 to 10. When we plug in our bounds, we end up with 3 plus 1 over 5, and then this simplifies to 16 over 5. Now we can also write this as a dollar amount since this is an insurance payment, and that would be $3.20. So that's how much the insurance company is expected to pay. So now moving on to the second part of our example. Here we're asked to calculate the expected value of the unreimbursed portion of the loss. So that would be the out-of-pocket cost for the insured person. Now in this part of the example, the unreimbursed portion of the loss is the part that we don't know. That's what we're solving for. So I'm going to use the variable Z to represent that. So when does the insured person need to pay money out of their own pocket for a loss? That's going to be when the loss is less than or equal to the deductible. We'll also need to make sure to include the lower bound of our interval, which is 0. So this is the instance in which the insured person would need to pay, but how much? Well, the insured person would need to pay the total amount of the loss when the loss is less than the deductible. Now there is another instance in which the insured person would need to pay, and that's when the loss is greater than or equal to the deductible. I'll include the upper bound of our interval as well. And when the loss is greater than or equal to the deductible, then the insured person needs to pay the deductible. So at this point, we have everything that we need to plug into our expected value formula. Because we came up with two different bounds, we'll have two different integrals. And the first will be from 0 to 2. And that's when z equaled x times 1 over 10 minus 0, which equals 10 dx. And our second integral is from 2 to 10. And here z equals 2 times 1 over 10 dx. I'll factor out constants from each integral. And then when we integrate, we're left with 1 over 10 times x squared over 2 from 0 to 2 plus 1 over 5 times x from 2 to 10. This simplifies to 1 over 5 plus 8 over 5, and that gives us a final answer of 9 over 5. As a dollar amount, this would equal $1.80. And there you have it. We found the expected value for how much the insurance company would need to pay, and we found the expected value for how much the insured person would need to pay. If this video was helpful for you, give it a thumbs up, like the video, and subscribe to the channel for notifications on more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.